Okay, welcome back to Calculus 2. We are going to be looking at problem number 3 here. So let's go ahead and get this thing set up. There we go. All right, it's set up. Where is my pen? We are right here. So we're going from 0 to 16, square root of y to 4 of x cubed plus 4. So let's have a look at what that looks like. So we have from 0 to 16. Let me go back 1 second here. We have square root of y to 4. Square root of y to 4. Okay, and then we have the square root of x cubed plus 4, I believe. X cubed plus 4, x cubed plus 4, dx by dy. Dx by dy. So I'm going to go ahead and write a little x in here. I'm going to write a little x in here. We're going to write a little y in here. We're going to write a little y in here so we can kind of get the region of integration. The easiest way to start doing this, and I hate to tell you this, is like, okay, we're going to graph this. Not this piece, but we're going to graph the limits of integration. So I don't really want to deal with graphing y equals square root of y. So off to the side here, I'm going to say x equals the square root of y. I don't want to graph like that. So we're just going to square both sides, and we're going to get x squared equals y. Can we graph that? I think we can. Okay, so we're going to go for y equals x squared. This would also be x equals the square root of y. Okay, and we're going to go between x goes from 0, 1, 2, 3, 4. Okay, so we'll go ahead and say 4 here. And I guess I could make a slightly better parabola that's going to fit what's going to happen there. So we're going to go ahead and do this. Just draw a dotted line up, x equals 4. So we're just going to have our parabola looking something like that. Okay, and over here, y was equal to 0 to, I believe, 16. 16. Here we go. All right. So right now we have dx by dy. So what you're going to do is you're going to say, okay, let's choose a y. Okay, like that one. And then, so choose an arbitrary y that's in your region. And we're just going to draw a line over. Okay, we're just going to say, okay, we've chosen a y. We're going to go in the x direction now. So we're just going to go through the x direction and see where are we in this region. To find out, we enter here and exit here. Okay, that tells me that the region that we're integrating is this region right here. We're entering here, exiting here. So this is the region we actually want to integrate for. Okay, so that's an important thing to do, is like make sure you're getting the correct region, because sometimes they can flip on you, but that makes these a little bit tricky to kind of deal with. Okay, so really now when I want to swap the order of integration, I want to say, okay, well, what's y going to be doing? This is the region of integration. So think about our y and our x. Let me go ahead and do this. And we'll go ahead and do this. So my y part, I want this to happen for the y direction. We are entering in at y is equal to 0 and exiting when y is equal to x squared. Okay. So what I'm going to be doing here is we're going to swap the order of integration. We're going to go from 0 to x squared. Okay. And then what are we doing for our x here? Because this is our y is equal to. So we have a dy now. X is going to go from 0, yeah, from 0 all the way up to 4. Okay, just like we have 0 all the way to 4. So the x part is going to go from here to here. And then we're going to say, okay, this was the square root of x cubed plus 4. There we go. All right. And I'll go back to using my other colors just so I can finish out the problem here. And we're going to be going ahead and doing that. Okay, dy by dx. Okay, so fortunately, this whole thing, like now I'm integrated with respect to y. I don't really care about anything in here anymore because it's all in terms of x's. It's considered to be a constant. So let's go ahead and integrate with respect to y. So we're going to be saying, okay, I've got between y here. Okay, so we're going to be from 0 to 4. And then we're going to have x cubed plus 4. Okay, and I'm integrating with respect to y. So we're going to be, okay, this is now y. Going from 0 to x squared. Okay, and we still have to go through dx. So let's go ahead and deal with that. So we're going to have this cube root, I'm sorry, the square root of x cubed plus 4. Okay, x is going from 0 to 4. Y is going from x squared minus 0. Okay, and we still have to integrate dx here. Okay, so what's going to happen here is now, see, when we first looked at this integral, we couldn't do it. Okay, I can't, there's no u substitution for this. We'd have to do something extraordinarily clever to figure out how to integrate this thing. Like, I'm not that clever. So what's going to happen is we needed to go x squared times the square root of x cubed plus 4. We're just integrating with dx now. We've already taken care of the double integral. Just got this. Now, there's a u substitution we could deal with, right? We could say set u equal to x cubed plus 4. du is equal to 3x squared. And we can go ahead and say, okay, if I put a 3 here, I've got to multiply by 1. So I can't just add 3 to anything or multiply by 3. I've got to say 3 or third here. This part here, this 3x squared dx is going to fit for my du. And then we're going to have the integral of u to the 1/2 power. Okay. Now we could do one more thing here. I could say when x is equal to 0, plug in x equals 0, we get u is equal to 4. So we have u is equal to 4 here. When x is equal to 4, we get 4 cubed plus 4. That's going to be 64 plus 4, which is 68. So we're going to be going from 4 to 68 for u, because now we're in the u world. And we're just going to integrate with respect to u here. Okay. So we can go ahead and integrate that. That's just going to be integrate. So don't forget to do that. So that's going to be u to the 3/2 times 2/3. And we're going from 4 to 68. Okay. So we can go ahead and just type that in. So we're going to say this is 2/3 times 68 minus 4. 68 to the 3/2 minus 4 to the 3/2. Okay, I'm sure these are delightful numbers, but that's kind of what you're dealing with. Okay, you can get to a calculator and go ahead and do that. I wouldn't be too upset if you left it just sitting like this, because 68 to the 3/2, I don't know, 4 to the 3/2. That's not going to be so bad, but 68 to the 3/2 is awful. Okay, so that's how you do that kind of a problem. Swapping the order of integration can be a little bit tricky. I do always recommend draw the region so that you know, like, which region are you actually integrating over, so that you make sure you're getting the right one. Okay, and again, go ahead and set the x, go ahead and draw it in the, or set the y, draw it in the x direction first. And then when you want to swap, you swap directions. So just so you can define what region you're on. Okay, so these can be very tricky. So just be careful when you're trying to integrate and trying to swap the order of integration. It's not like, I'm just going to switch. Like, you can't do that. Be careful about your order of integration. Be careful about your limits of integration. That's where the tricky part comes in. Okay, so I'm going to say thank you very much for watching the video. I hope that helped a little bit. Good luck for studying for exam. Okay, see you in the next video.